Hello, ladies and gentlemen. We're going to do some factoring today. So, factoring's a big deal. Before we get into the factoring, we're going to make sure we can sort of go forwards. And you imagine sort of factoring is undoing, going backwards. So, we're just going to practice combining like terms here to start. You want to look for the highest degree when you're simplifying. Now, in this first problem, it's a plus sign. So, if you want to put little ones on the outside of these parentheses and distribute little ones, you can do that. But the parentheses essentially don't matter. Addition is both commutative and associative, so you can ignore them. You do need to look for like terms, so let's find the highest degree first. You have 6 n to the fourth and negative 7 n to the fourth, so that would be negative 1 n to the fourth. I'll just put minus n to the fourth. Then we'll do negative 7 and positive 3, that makes negative 4n cubed. And then you just have the plus 8 on the end. So you're just combining like terms, no big deal. Same thing here, another addition problem, so we'll do the same thing. You have negative 2n to the fourth and positive 2n to the fourth. Those cancel each other out. You have only one n cubed, so that's n cubed, negative 2n cubed. And then you have 2n and 3n, which make 5n. So negative 2n cubed plus 5n. Nothing too fancy. This next one, though, does have a minus sign, so you do need to remember that you're distributing the negative. So it's going to be minus 8m to the fourth, and negative times negative is positive 3m squared. This won't change because it's a positive on the outside. So I get rid of the parentheses first. Now I need to combine like terms. So I'll look for n to the fourth. 1 minus 8 is negative 7m to the fourth. How many m squareds do I have? 4 plus 3 is 7m squared, and then you just have a minus 1 on the end. Last one's another addition problem, so you can kind of ignore the parentheses. You have 3x to the fourth out front. Let's see, do we have any x cubes? Nope. Negative 6 and positive 3 make negative 3x squared. And then you have negative 3 and positive 6x, which make positive 3x. 6 minus 3 is 3. That's just combining like terms, nothing too fancy. Now, what if we are asked to distribute? So I'm going to make sure that we understand what's going on here. Everything in the first polynomial has to get multiplied by everything in the second. So n has to get distributed and negative 2 has to get distributed. If you want to write that out, you could say n has to get distributed and negative 2 has to get distributed. So there's 4 multiplications that have to happen. N times n is n squared, n times negative 1 is negative n, negative 2 times n is negative 2n, and negative 2 times negative 1 is positive 2. You will usually have like terms in the middle. So there you go. Now, some people just kind of do this game. Fine. You can remember FOIL, whatever it is that you do. I don't care. But just understand that if it is a binomial with 2 terms and a binomial with 2 terms, there must be 1, 2, 3, 4 multiplications. It's a 2 by 2, so there will be 4 multiplications. The next problem. You have an exponent. You cannot, and you never have been able to, distribute exponents. I know why you say that, because you see something like this, and you say that's 4 squared n squared. That's not the same as this. This minus sign is what's going on here. This is not the distributive property, even though it kind of looks like the distributive property. It's not the distributive property. The distributive property requires addition or subtraction. You cannot distribute exponents. You never have, you never will. When you see a quantity squared, you should just write it out. 4n minus 2 times 4n minus 2. That's what it means to square something. It's to multiply it times itself. And the reason that matters is because people will just try and distribute the exponent and they'll get something like 16n squared, either plus or minus 4. It doesn't matter, they're both wrong because you're missing the middle term. So don't do that. Make sure you write it out and then you're going to FOIL it like you do all the other problems. So I'm going to multiply 4n times 4n and get 16n squared. 4n times negative 2 is negative 8. Again, negative 8. 4n times negative 2. And then negative 2 times negative 2 is positive 4. So 16n squared minus 16n plus 4. If you try and distribute exponents, you will get it wrong 100% of the time, and you will always miss this middle term. So 16n squared minus 16n plus 4. Well, what if it's a binomial times a trinomial? 2 terms times 3 terms. You know that if there's 2 times 3, you're going to have 6 multiplications in this problem. So the 6 multiplications are 5m has to get distributed, so I'll do that. 5 times 1 is 5, and m times m squared is m cubed. 5m times negative 8 is negative 40. That's going to be m squared, m times m. 5m times 2 is 10m. We're going to do the same thing here with the 4 now. 4m squared minus 32m plus 8. So we're going to need a bigger boat. Let's see if I can shrink this up a little bit. Scoot over anyway. Okay. Now let's combine some like terms. So we'll do highest degree first. There's only one cubic term, 5m cubed. Negative 40 and positive 4 make negative 36m squareds. 10 and negative 32 make negative 22m's. And then it looks like you just got a plus 8 on the end. Let's do another one like that. Now, this one had the binomial up front. This one also has the binomial up front. It doesn't matter if you go the other way. Some people like to distribute all three of these. You'll get the same answer. It doesn't matter. Put that in the background. Okay, so I'll distribute this guy. I'm going to go 6x times 7x squared. That's 42x cubed. 6x times 7x is 42x squared. 6x times 5 is 30x. Now we'll distribute the negative 4. Negative 4 times 7, negative 28, and that's x squared. Negative 28x, and then negative 4 times 5 is negative 20. Combine like terms. We got 42x cubes. We got 42 minus 28, which is 14x squareds. We got 30 minus 28, which is 2x's, and we got negative 20's just hanging on the end there. Okay, that's going forwards. Shouldn't be any major issues with that. Now we're going to start to factor. So let's start to factor. Now I'm going to go through this using the sort of a split the middle method. I do not care how you factor. I'll show you how I'm going to do them. You do them however you want. You're ultimately doing the same things I'm doing. There's no way to get around. Find two numbers that multiply to this and add to this. We're all playing the same game. We just might use slightly different notation. So factor completely. When you factor, the first thing that you always want to do is look for a GCF. Do these three things have anything in common? Do these three terms have anything in common? And the answer is yes, they are all multiples of 4. So I'm going to first factor out a 4. That's going to make this problem much more manageable. If you divide everything by 4, 40 divided by 4 is 10b squared minus 332 divided by 4 is 83b, and 252 divided by 4 is 63. Yeah, 126. Yeah, good. Okay, so that's the first thing I'm going to do. Now, that 4 on the outside, I'm ignoring it. I'm not looking at it for the rest of the problem. I'm just looking at the green. I'm just going to look at the green. Now, the way you factor a trinomial is you're going to multiply these two terms, 10 and 63. So these numbers multiply to negative 630. I'm going to need to find two numbers that multiply to negative 630. That's a big number. But I have to pick the right two. I can't just pick any two numbers. They also must add to the middle. The middle here is negative 83. Now, if you want, you can start to make a table for all the factors of 630. 1 and 630, 2 and 315. You can keep going. But I know the ones that I need are 7 and 90. 7 times 90 is 630. Now to get the negative 83, I'm going to make the 90 negative. Okay? So we're going to say 10b squared doesn't change, but I'm going to split the middle. I'm going to take this term and split it into 2. The two terms I'm going to use are right there. So plus 7b minus 90b minus 63. It's called split the middle because you take the middle and you split it into 2. I've split it into 2 terms now. The reason I do that is because now I have 4 terms and I can factor by grouping. So I'm going to factor by grouping, which means I'm going to find the GCF of the first 2 terms, which the GCF of the first 2 terms is b, so that will be b, 10b plus 7. Bring down the minus sign. The GCF between 90 and 63, those are both multiples of 9, so I'll factor out a 9, and that would be 10b, and then be careful, negative 63 divided by negative 9 is positive 7. So if you do it right, this should happen. You should have a binomial that they share in common. I'm going to say that that is my new GCF, 10b plus 7, and if you factor that out, you are still left with b minus 9. Now I've got the middle factored, but I did have that 4 on the outside, so even though I haven't been writing it, that 4's been out here. Okay, I'm going to just write it down in the end and say, okay, that's it. That is my completely factored polynomial. If you want to check your answer, you can FOIL this out, and then you can distribute the 4, and you should end up back where you started. So let's keep going. Same game. I'm going to multiply the leading term and the last term. There's no GCF here. This is a multiple of 3. This is a multiple of 2. So I know there's no GCF. I need to multiply 9 times 16, which is 144, and find numbers that add to 144 and multiply to 144 and add to 24. Now, that's a perfect square. I know that's 12 squared, so that actually is kind of easy. This is going to be 9x squared plus. So the numbers that do this are 12 and 12. 12x plus 12x. Now I can factor by grouping. The GCF of the first two terms is 3x. The GCF of the second two terms is 4. And one of my factors is 3x plus 4. And the other factor is 3x plus 4. So this is actually a perfect square trinomial. So you can write your answer as 3x plus 4 quantity squared. Either of those are correct. Sometimes you want the squared, sometimes you don't. It just depends what you're trying to do. So either of those is acceptable. Let's keep going. All right, we got a few more problems that are very similar to the ones we just did, so I'm going to go pretty quick here. I'm going to just make sure we have some extra problems to do. First thing, big GCF. The big GCF, what do all four of these have in common? I think they're all multiples of 4, so I'm going to factor out a 4. And now I have 9x squared plus 12x plus 4. Is that right? Now, I'm checking to see, do these three terms have anything in common? 9, 12, and 4. If they do, I should have factored it out in the beginning. But they don't, so I know I have the greatest common factor. Not just a common factor, but the greatest common factor. Now I can play the same game I've been playing, multiply those two, find numbers that multiply to 36 and add to the middle. The middle is 12. So what multiplies to 36 and adds to 12? That's another perfect square. 9x squared plus 6x plus 6x. 6 times 6 is 36. 6 plus 6 is 12. Now we do GCF. 3x plus 2 plus. GCF here is 2. 3x plus 2. And I end up with, you can see 3x plus 2 and 3x plus 2. So I'll just write 3x plus 2 squared, and then that 4 has just been hanging out front. So 4 times 3x plus 2 squared. Next problem has 4 terms. So you have a cubic. This is actually easier. This is sort of a split the middle problem, but the middle's already been split. Although in this problem, they're not really like terms, so it's just a 4th degree polynomial, or 3rd degree polynomial. We're just going to do grouping. With 4 terms, you're going to factor by grouping. So the GCF here is x squared, 3x plus 1. Bring down the plus sign. 3 and 1 don't have anything in common. We'll just say they have a 1 in common. It's sort of like a placeholder 1. So my factors are 3x plus 1, and then what's left? X squared plus 1. Now you always want to look to see if this is factorable. If it's not linear, if it's higher than degree 1, it might still be factorable, and x squared plus 1 is not factorable. So we're finished. All right, second one has 2 terms. So this one's kind of a trick. You might remember that this is sort of like a square root game, like the square root of 16n squared. The square root of 16 is 4, and the square root of n squared is n. So it's going to be 4n. The square root of 9 is 3. And this is called a difference of 2 squares. If I want to get a minus sign, I need to put a plus and a minus, because positive 3 times negative 3 is negative 9. This is called dots, or a difference of 2 squares, because these are both perfect squares. Now, you can kind of check it. If you FOIL it out, you're going to get 16n squared minus 12n plus 12n. Those cancel out, minus 9. So the reason that this works is the outer and the inner terms cancel out. Next one, let's see. I think all I can do here is GCF. So the GCF is 2x, and I have 5x plus 2, and that's it. So sometimes that's all you can do, GCF. Okay. Couple more. This one has 4 terms, so it's going to be a grouping problem. But first, let's see if they have a big GCF. If you can just see that these two don't have anything in common, you're done. You don't even need to think about those. Like, oh, they have 5. Who cares? 7 and 3 don't have anything in common. We're done. So we're going to factor by grouping. So we're going to factor the first 2 terms. That would be 7x squared. And you would have 5x minus 1. Oops. Bring down the minus sign. GCF between those 2 terms is 3. And you have 5x minus 1. The reason it's minus is because you got to think negative 3 times what gives you positive 3. Negative 3 times negative 1 gives you positive 3. And that also helps these things match up. So one of your factor now is 5x minus 1, and what's left is 7x squared minus 3. You should again check to see if that's factorable. That's not a difference of squares, so we are finished. One more. Big GCF, let's see, this is 2 times 5. This is an even or multiple of 5, so there's no big GCF. I need to multiply the leading term, so 10 times the constant, 56, that's 560. I got to find numbers that multiply to 560 and add to negative 51. So what multiplies to 560 and adds to negative 51? Let's see, this is going to be 35, 16 and 35. That adds to 51 and multiplies to 560. Now, the fact that they have to add to negative 51 means they are both negative. So I'm going to say 10v squared minus 16v minus 35v plus 56. How do I get those numbers? You just got to keep trying. Divide by 1, divide by 2, divide by 3, divide by 4, divide by 5 until you get the right 2. I can show you how to make a table on your calculator, but it's basically just figure it out. Just keep trying until you get the numbers that you need. So what do these first two have in common? They're both even, so 2v, 5v minus 8. Bring down the minus sign. What do those two have in common? 7? 5v minus 8. Again, negative times a negative is positive. So my factors are 5v minus 8 times 2v minus 7. Doesn't matter what order you write those two in. That is our basic factoring review. That's pretty much everything that you need going into what we're going to do next, which is going to be some higher degree polynomials and some fractional exponents. So you have some Khan Academy exercises to complete. Go ahead and get those done, and good luck.